Good day everyone, how are you today? Today we are going to study about the converse, inverse, and the contrapositive of an if-then statement. By the way, I am your teacher, Ma'am Isa C. Swicon. Do you think it is possible to make a valid conclusion without even going through the process of investigation? What would you do if you are going to make a decision that will affect many people? Geometry deals with the logical reasoning to prove a certain statement. In this video lesson, you are going to find the answer on the questions how to make a valid conclusion and how can you show that your conclusion is valid. The objective of this video lesson illustrates the equivalence of the statement and its contrapositive and the converse and inverse of a statement. Let us have a review. If-then statement is also called a conditional statement, which is formed by joining two statements P and Q using the words if and then. And P statement is called hypothesis and Q statement is the conclusion. So let's try. Convert the statement into if-then form and then identify the hypothesis and the conclusion. So here is the statement. A triangle is a polygon. The if-then form is if the shape is a triangle, then it is a polygon. So the hypothesis here is if the shape is a triangle. And the conclusion, then it is a polygon. A conditional statement, however, has three other related statements, namely converse, inverse, and contrapositive. So we have here a presentation. Okay, conditional statement. P implies Q, or we can read this as if P, then Q. Next is converse. Q implies P. If Q, then P. In inverse, not P implies not Q. If not P, then not Q. The contrapositive, not Q, implies not P. Or if not Q, then not P. The converse of a conditional statement is formed by interchanging the hypothesis and the conclusion. Remember, the converse of a conditional statement is formed by interchanging the hypothesis and the conclusion. Ayan. For instance, the converse of P implies Q is Q implies P. It may also be true or false. Not all the converse is true. Sometimes it is false. For example, the conditional statement, remember, if P then Q. If you live in Masbate, then you live in region 5. So the P statement here, if you live in Masbate, and the Q statement here, then you live in region 5. The converse, we have to interchange the hypothesis and the conclusion. If Q, then P. If you live in region 5, then you live in Masbate. The Q statement here, if you live in region 5. And the P statement here, then you live in Masbate. So we have to check if the conditional statement is true or false. If you live in Masbate, then you live in region 5. Of course, this is true. How about the converse? If you live in region 5, then you live in Masbate. This statement is false because Legazpi is also part of the region 5, not just Masbate. So in this case, the conditional is true, but the converse is false. We have here another example of converse. So the conditional statement, if a number is even, then it is divisible by 2. Remember the conditional statement, if P, then Q. So the P statement here, if a number is even, and the Q statement here, then it is divisible by 2. So what is the converse? Remember, the converse of a conditional statement, we have to interchange the hypothesis and the conclusion. So the hypothesis is the P statement and the conclusion is the Q statement. So if a number is divisible by 2, then it is even. So we have to check if in the conditional statement, if a number is even, then it is divisible by 2. Of course, this is true. All number that is even is also divisible by 2. How about the converse? If a number is divisible by 2, then it is even. Of course, this is true. In this case, the conditional is true and the converse is true. Now we have to use the biconditional statement. So what is the biconditional statement? The two statements can be combined using if and only if. So the new statement here is a number is even if and only if it is divisible by 2. Let us have another example of biconditional statement. The conditional statement, if you are a civil engineer, then you pass the CE board exam. So the P statement here, if you are a civil engineer. And the Q statement, then you pass the CE board exam. So the converse of this conditional statement, if you pass the CE board exam, then you are a civil engineer. Since both the conditional and the converse are true, the biconditional, or we can use the biconditional statement. So here is the biconditional statement. You are a civil engineer if and only if you pass the CE board exam. Next is inverse. The inverse of a conditional statement is formed by negating both the hypothesis and the conclusion. Remember the word negating, both the hypothesis and conclusion. For instance, the inverse of P implies Q is not P implies not Q. Or we can read this as if not P, then not Q. So where is the conditional statement? If you obey rules and regulations, then you are a good citizen. So the P statement here, if you obey rules and regulation. And the Q statement here, then you are a good citizen. So what is the inverse? Remember, the inverse, if not P, then not Q. You have to negate both the hypothesis and the conclusion. So if you do not obey rules and regulations, then you are not a good citizen. So we have to negate the hypothesis first. So the not P. So the not P here, if you do not obey rules and regulation. And the not Q here, then you are not a good citizen. Next is the contrapositive. A contrapositive of a conditional statement is formed by interchanging the hypothesis and conclusion and negating both. Just remember, contrapositive, interchanging the hypothesis and conclusion, and negating both. For example, the contrapositive of P implies Q is not Q implies not P. Or, if not Q, then not P. Parang binaliktad lang po yung inverse. Yeah, so the conditional statement, if P, then Q. If it is a chicken, then it is a bird. The P statement here, if it is a chicken, and the Q statement here, then it is a bird. So what is the contrapositive of this conditional statement? If not Q, then not P. So if it is not a bird, then it is not a chicken. So not Q and not P. So we have here another example. So the statement, students who are good in mathematics are smart. The conditional statement, if P, then Q. If you are a student who is good in mathematics, then you are smart. The converse, if Q, then P. If you are smart, then you are good in mathematics. The inverse, if you are not good in mathematics, then you are not smart. And the contrapositive, if you are not smart, then you are not good in mathematics. Let us have another example. A rectangle has 4 angles. The conditional statement, if the shape is rectangle, then it has 4 angles. The converse statement, if the shape has 4 angles, then it is a rectangle. And the inverse, if the shape is not rectangle, then it has no 4 angles. And the contrapositive, If the shape has no four angles, then it is not rectangle. So kung makikita nyo, yung from conditional to inverse, lagyan lang natin siya ng word na not. Or dun tayo magbabase sa if not P, then not Q. Ganun rin from converse to contrapositive. Ganyan lang po kasimple. Another example, the statement, a number which is divisible by 2 is an even number. So the conditional statement, if P then Q. If a number is divisible by 2, then it is even. And how about the converse? If Q, then P. If the number is even, then it is divisible by 2. In the inverse, remember, if not P, then not Q. If the number is not divisible by 2, then it is not even. In the contrapositive, if not Q, then not P. If the number is not even, then it is not divisible by 2. Remember, in inverse, you have to negate both hypothesis and the conclusion. That's why you add not, the word not, or sometimes the word no. And then in contrapositive, remember, you have to interchange the hypothesis and the conclusion and negate both. Next is, what is logically equivalent? It is two statements are logically equivalent if they have the same truth values for every possible interpretation. It can either be both are true or both false. Now we have an example. If the shape is rectangle, then it has four angles. In converse, if the shape has four angles, then it is a rectangle. In an inverse statement, if the shape is not rectangle, then it has no four angles. Sa contrapositive, if the shape has no four angles, then it is not rectangle. So let's check if the conditional statement is true. Yes, it's true. And how about the converse? If the shape has four angles, then it is a rectangle. It is false, because not all shape has four angles is a rectangle. We also have a square. And in the inverse, if the shape is not rectangle, then it has no four angles. Ayan. Meron ding example or meron ding ibang shape na four angles kahit hindi sila rectangle. Next is the contrapositive. If the shape has no four angles, then it is not a rectangle. So this statement is true. So the condition statement is logically equivalent to its contrapositive. Since the conditional statement and the contrapositive are both true, so they are logically equivalent. And the converse and inverse of a conditional statement is logically equivalent to each other, since converse and inverse are both false. But neither of them is logically equivalent to the conditional statement, since the converse and inverse are both false, but the conditional statement is true. So they are not logically to the conditional statement. We have another example of logically equivalent. So the conditional statement, if a number is divisible by 2, then it is even. Is it true or false? Of course, it is true. Next is the converse. If the number is even, then it is divisible by 2. Is it all even number are divisible by 2? Of course, the answer is true. If the number is not divisible by 2, then it is not even. Lahat ba ng number na hindi divisible by 2 ay hindi rin even number? The answer is true. If the number is not even, then it is not divisible by 2. Lahat ba ng hindi even number ay hindi rin divisible by 2? Of course, the answer is true. Therefore, the converse, inverse, and contrapositive of a conditional statement are logically equivalent to each other. Now, the question a while ago, how do you make a valid conclusion? Of course, we have to go through the process of investigation. And to show that our conclusion is valid, we have to present the step-by-step process. Here are the references. Thank you for watching, and I hope you learned something today.